So these are the people on our team and their roles, and we'll begin by introducing ourselves. I'm Sam Albert, the project manager.
I'm Alex Marshall. I'm the project's partner liaison, and I'm on the CEB team.
I'm Dana Hayes-Camp. I'm financial officer and the cultural liaison for the CEB team.
I'm Nick Chittick. I'm the design lead for the CEB team.
I'm Troy Mormon. I'm the project archivist and part of the materials analysis team.
I'm Brock Smith. I'm a writer for the grant team and the webmaster team.
I'm Nick Mack. I'm on the grant team and I'm also on the CEB team.
I'm Frank Vasquez. I'm the assistant financial officer and I'm also on the CEB team.
Hi, I'm Paige Curry. I'm a partner liaison and a cultural liaison for the MA team.
I'm Shanisha. I'm a member of MAT team.
I'm Sadie Argus. I'm the design lead for the materials analysis team.
Right, so that's our team, and I'll tell you a little bit about how the presentation will go. Okay, so we'll begin by giving you an overview of what our project is and what we've done in the past. We'll also give you a background on who our project partner is and some about them. We'll talk about our design process, where we are in it. We'll present a document that ties together different aspects of the project. Then we'll hear from our design teams and hear about what they've been doing. Finally, we'll talk about the budget for this semester and moving forwards, how we're going to be funding that, and look at the broader timeline for the whole project lifetime. So, we decided to break the team up into two main design teams. The first is the materials analysis team, which, well, actually, I'll start with the compressed earthquake team, which is looking at this technology we're interested in using in LUM-BC to build the community center or to be the external support. It has been tested, but not as thoroughly as other materials. So we're looking to do a prototype of our method. In case that doesn't pull through from testing, we have the materials analysis team, which is looking at many different options for materials so that if CEB doesn't work out for us, we know what other material we want to use and we have engineering evidence for that decision. We also have several other smaller teams and roles. The primary one are the cultural liaisons because they're focused on making sure we learn more about the culture constantly and keep our project relevant and informed on what's going on in LUM-BC and what exactly our project partners want. But we also have people doing the website, people working on budget, people working on applying for grants, and the project archivist. So, yeah, so now you hear from Paige about who our project partner is.
Our project partner is FEVI. Can you see me here? Or?
You're good.
Okay. Which stands for Foundation for Education and Volunteer. I forget the rest of it, but I will know it for Wednesday. They were recognized in 2005 by the Ecuadorian government as a nonprofit organization. FEVI supports education in low-income areas and promotes local and volunteer work. So some of the projects that FEVI has done in the community LUM-BC that we're working in includes like making an organic garden for the whole community just to pick from and like get vegetables from and plant there. Also, they built the existing school that we're going to be kind of adding on to with our project. And next I'm going to talk about, if you could press the button.
Oh, shoot.
Thank you. Our project background. So this project started in kind of fall of 2012 as just an idea from a grad student named Jorge. He brought it to the global engineering program to be a global design team. In the next semester, like Brandon Falk, who's our advisor now, he kind of accepted, like saying, yeah, I'll be a part of this team and I'll like head this up. So shortly after he accepted that offer, he went to LUM-BC to visit and kind of build a relationship with the community and meet all the people we were going to be building this for, especially like these little kids, as you can see in the picture. Brandon met these 3- and 4-year-olds that use the classrooms that we're going to be making for them, and also some of the community members that are going to be using the upstairs elements of the center. And then in spring 2013, we kind of had a team form. During that time, we realized this is a really long process of like designing a community center. So then we decided to go down there and build a handicap ramp because that was a need at the school because they had a little boy that needed handicap access to the building. So we went down there during spring break and built this handicap ramp as you see in this middle picture here. And then the next fall, another need that the community wanted to have taken care of was a set of bleachers so that the parents would have a place to sit during school functions such as like plays and sports events and everything. So a team of like 14 people went down and we built these bleachers as you see in this bottom picture, and it was a really great time and a really cool experience because we got to really build community, and the people of Limbisi actually saw us there and saw that we were invested in the community because we had been like more than once. So now we are kind of continuing relationship with them, and part of that is we've kind of had a problem with because not a lot of people that we know from Limbisi have access to internet, or like we can Skype them or email them or something. So we've been kind of brainstorming about who can be kind of key informants or key people that we talk to during this design process, so we make sure we are doing what they want and we have like the correct specifications, and so that we aren't designing something they're not going to use in the long run. So as part of that, we've kind of developed a few people. So there's like a community government called the Cabildo, and we are going to be in contact with them a lot more often than we have been this semester. We're going to be sending them questions and kind of the things we've been working on, and just setting up that communication like probably once a week of just like an update of what our team is doing, and like so they can give us feedback and give us comments and questions and concerns that they have for the whole community. The other people that we're kind of going to be talking to include one grad student. His mom's like maid lives in Limbisi, and so we're going to be using her as a key informant, hopefully. Also, the school principal Jaime, and any study abroad students from UIUC, which we've been in contact with a few of them before, but hopefully next semester more of them will be willing to kind of talk to their host families that if they're living in Limbisi about what our project is about and what we're doing here in the US, so that everyone knows that we're still involved and we're still there. And then the ways we're planning on doing this is kind of through email, and then like our project partner kind of printing stuff out and bringing it to the community, and or like emailing the key informants I talked about, because I think they do have email or a way we can indirectly email them and get them the information somehow. So you can see I provided a document and you can see kind of our questions that we have for them that we're going to be sending them soon. It'll obviously be translated into Spanish, but you can kind of look through that and give us any feedback you may have on that. Oh, and next Claire will be telling you a little bit about the work we've done.
You can just do it from your seat.
Yeah.
Do it from my seat. Yeah.
Do you want to just, film
I mean, I could hop up there. Okay.
For the real thing.
Yeah.
For the real thing, I'll hop up there. Okay. So the previous teams have done a lot of work already. A lot with documentation, but they did not document how Epics wanted it to be documented, so a lot of my job has been to transfer documents over to SharePoint and get everything in one spot. What you see on the screen are previous renderings that the teams have done. So in the bottom left, there are bleachers. That's from the bleacher project that Paige talked about. And then the two pictures on the right side are both of the community center. Obviously, some things have changed, so those will not be used as much. As project archivist, I have learned many important things about documentation. Biggest lesson I've learned is that we are documenting more for our project partners and for our future teams than we are for us. I say that because we know all the information and why we make each decision, but if we don't write it down and document it, then that information is gone when we leave. There might also be another lesson that I've learned, possibly for the presentation. As of right now, I'm not sure. So usually I turn it over to Nate to talk about the website.
Alright, so I'm the webmaster who was in charge of creating the website that had most of the information that our team has collected so far. So I was challenged to do this by Brandon, and it was definitely a big one that I had no idea absolutely what to do with this because I had no background in HTML or any kind of coding language that involved the website. So it definitely took me a long time to do, and probably a lot longer than it should have. But I'm pretty proud of what I came up with so far. So this is just a few screenshots of what the website looks like. Here's a home page that has a little bit of information about who we are, and then also the 3 team leaders and links that lead to the other ones. This is a page about the members, each person's name and also the title of what they do. And this is our project partners that gives a brief description about who our project partner is and where we're working. And go to the next slide. This is the rest of the pages. This one talks about the projects that we've delivered so far and what we will be delivering in the future. And this is also contact information in case anyone who is looking at our website wants to know more information or has any questions. So this is what I spent most of the semester working on for our project. Then hand it off to.
Okay. Alright, so as you saw on our decision matrix, we completed all of the materials other than the CEB. So over the summer and next semester, we plan on completing it for the CEB using the research that we gathered. And then we hope to determine our best alternatives. Well, we will determine them. We will create a list and a document explaining which ones we have chosen. This is our Gantt chart. You can see we're in week 14, so we are wrapping up the decision matrix and determining the materials that we are going to use. And now I'm going to hand it over to Nick with the CEB.
So our group has been mainly focused on this one type of technology called CEB, which stands for compressed earth brick. And we've really been into the design and then manufacturing this, and then we're going to be into testing it over the summer. But what CEB is it, as the name suggests, it takes earth and compresses it into bricks, and they are usable bricks. And this method is cheap because the only material needed is the dirt that's already dug up during excavation. And for the same reason, it's also sustainable because we're not using outside sources for material. And so basically what happens is you have a mold that holds dirt in it, and you have something that compresses it down, a compressive force. And from the research we've done, it's looking like we're going to need 3,000 psi or pounds per square inch for it to go from loose dirt to a brick. So we were coming up with a technology that could do that. And then this semester we've been working on coming up with a working prototype, and actually as of hopefully Tuesday night, Wednesday morning, we'll have that finished and we'll be able to start testing. And then I guess now I'd talk about the model, whether we have it or not. Go ahead and go to the next slide. So this is what we have so far, and actually as of our Wednesday lab, this will be we'll have made slightly more progress in this, but what happens is we have this right here is a hydraulic log splitter, and it should I explain its intended purpose in this, or not worry about it?
You can give a brief explanation.
Okay, so it's a hydraulic log splitter, and its intended purpose is this hydraulic arm right here moves forward with an axe head on the end, and it would split wood to be used to heat homes or what have you. But what we've done to it is we have taken the axe head off and put a head press attachment on it that will move forward in the same way, but it'll compress the dirt that's in the mold. And this is a picture of what we have so far. So there's your hydraulic arm, and then you have that handle right there that we use to crank to move the press forward, and then this would go into a mold. And then I probably have my wood prototype mold like last time. And then this is what we have so far, and Seth Parker, who is the person who has done all the metal manufacturing with us, also owns a sign business, so he was nice enough to do custom decals on the side, which I think is a pretty cool touch he did for us. We can go to the next slide. So this is a demonstration of it. I'll cue you before you actually play the video, because I want to explain some stuff. This is a demonstration of it in use to show that what we have right now does work. Now there will be a mold right there once we get into testing, but what I'm going to do is I'm going to crank the handle forward, and for safety purposes, to move it forward, you have to have your hand on the handle, but you'll notice whenever I pull the handle back, you can let go and it'll move backwards. So you can go ahead and play the video.
See if we can put that in the PowerPoint a second time and if it'll actually go full speed.
I mean, it can work in slow motion, it shouldn't be.
Yeah, sure.
Yeah, and that was very own Frank in the
Yeah.
background. The sound effects on the video. But yeah, what that showed was that, you know, it does move forward, and the base plate that, this is Seth Parker, the base plate that he's attached to it fits very well. It was very well made. So we're really excited about what that has to offer, I guess, and I'll reword that tomorrow. Next slide. And then Frank is going to talk to you a little bit about the pros and cons of what we made, as well as what we were originally looking at and what has changed since then.
Alright, so when we were designing, or coming up with the idea for the CB press actually, we came across this design by a company called Open Source Ecology, and this machine was what we were originally going to go with, but it is very expensive and all custom, so it would take a lot of work to make, and we didn't necessarily really have the skills to do that. So Nick came up with the idea to use a log splitter to make our compressed earth bricks, and the log splitter is actually the same exact thing as this machine. This just has a hydraulic press that compresses the bricks, except it has a conveyor belt and then a spot where you load all the dirt in. And so, unlike this one, our log splitter is mostly manufactured, so it decreases the risk for, you know, it breaking down in the field greatly. Our log splitter also operates on gasoline. This machine operates on electricity only, so we'd have to have a cable tethered to it wherever we use it in the field. The CV press we're also being, we only remove the head, so it is capable of actually being converted back into a log splitter. Should we just use that as an option to leave in Ecuador or take it with us or whatever we want to end up doing with it. Log splitter is also mobile. This thing doesn't have any wheels at all, and you have to disassemble it to take it places, and it's just problematic. It's insanely heavy. Our log splitter has wheels on it, so we can put it on the back of the truck and drive wherever we need to. It's also manual start option, so in case our battery for some reason ends up going out or anything, you can start like a lawnmower. You just pull the cable. The battery's just there for convenience. CPU bricks are also actually stronger than Adobe bricks. The New Mexico standard for Adobe is, I believe, 300. I don't know. I'll figure out that for Wednesday. I forget what the exact numbers are. But yeah, basically earth bricks are way stronger. Some cons for our design are nearly our entire process is going to be manual with the exception of pulling the lever to get the head press to go down. You have to load the dirt into the molds and then remove them, you know, with human power. And so it's much slower than this brick press. And we do need to make several molds to have like kind of a line going. And also the molds are rather heavy. Okay, so what we have done so far regarding our CV press is we've sealed all the high pressure areas with Loctite 545. That's kind of like an epoxy like pipe sealant, like super glue. And this is us, me and Nick took off all these like high pressure valves and coated them in it and fittings, yeah, and we put it back in, didn't know the word. And then the head, which you saw earlier, and that whole assembly was built courtesy of Mr. Seth Parker. He also built a prototype for the mold and a removal system for it. We've obtained hydraulic fluid, oil, and gasoline. As you can see, we had it running, and we've successfully tested the machines a few times. So the first time was not the only time we tested it. And then we still need to repair the wheels. They were damaged, transporting it to the machine shop. So we're gonna make it a little bit tighter fit, so there's almost no wiggle at all when it goes down the beam. And then we also need to refine the mold system, so we just have a prototype for that right now. And then I will pass it to Alex to talk about looking at.
While we have made a lot of progress, there is still a few things that we need to do this summer. First of all, we need to finalize the soil composition. We are working with a technical school in Lubisi to conduct a soil analysis, so that while we're conducting our tests, we will have the same soil that we will be using in our final project, so that we don't have any unforeseen errors that could occur based on the differing soil composition. And then we'll need to actually begin our tests and analyze the results that these tests provide. And we'll finally need to plug the results that we find back into the framework of the decision matrix, which the MAT team has already provided with us. And we are determining whether or not this is the best material to go ahead and use. As you can see on our Gantt chart that we developed in the beginning of the semester, we are actually on schedule, and we are currently determining the tests and finalizing the prototype that we have. So we are right on track to where we thought we would be. Now I will be handing it over to Dana to talk about the budget.
Okay, so originally from Epics we get a $200 budget, and then we also, upon submitting a budget information to Epics, we can get an additional $1,000 from them. We were also able to get a service learning grant at the beginning of the semester for $1,500. However, that was voided when we decided to go with the hydraulic log splitter power instead of manually making our whole process. The log splitter was ordered in the meantime, so Epics decided to cover that for us, which was very nice of them. The steel, we estimated around $500, but that's a very rough estimate because we're working with the steel fabrication guy, Seth Parker, as mentioned before, and we're not sure where we're going to end up with that at the end. We went ahead and purchased oil, hydraulic fluid, and gas, and then towards the end of the semester, we were able to get the Purdue Engineering Student Council grant for another $1,000, leaving us at this total. As I said, Epics funded our log splitter purchase, and so we were kind of being really careful with our budget from after that, and then we were able to get that Purdue Engineering Student Council grant to give us a little more leeway with our budget. As I mentioned about the steel cost, we still are looking to get the finalized budget for that as we finish up with the steel production.
And as Dana said, we're determining the cost of the building during research this summer. And right now, we're continuing to look for grants. As she said, we were able to find and receive a couple of them at the beginning of the semester, and that helped us fund this semester's activities. And now we're starting to look at stuff that's actually going to fund the actual trip for construction down there. Currently, we're looking at big companies to like fund us, or nonprofits to help fund us, but we just haven't found the right fit yet, and we're currently looking for that.
Alright, so in conclusion, this is just a look at the timeline for our entire project, looking mostly beyond this semester. So this first block, these are our goals for this semester, and we've accomplished all of them aside from the prototype is maybe finished, we'll see. And looking forwards, we're going to be doing testing over the summer, and that's going to be crucial. In addition to that, we still need to finish determining which design work is going to be applicable. And it's one of our other medium-term goals is learning as much as we can from the global development team members, continuing to use them as a resource as much as we can before they graduate. And then our really long-term goals are designing the community center, putting a plan in place for actually building it, and then building it. Goals that stretch throughout this whole process are making sure we're learning more about the culture in Lumbisi and maintaining the relationships we already have while building other relationships. And of course, we want to make sure we're obtaining funding as quickly as possible so that that doesn't hold us back from delivering this project. So that's it for our presentation, and we'd be happy to answer any questions.